Hello Year 5, welcome to Tuesday's maths lesson where we are going to be multiplying non-unit fractions by a whole number. So yesterday we multiplied unit fractions, which is fractions of with a numerator of 1, so 1/2, 1/4, 1/5, etc. by a whole number. Today we're doing non-unit fractions, which are any fractions that do not have 1 as their numerator. So that can be 2/3, 7/16, anything where the numerator is not 1, okay? For example, these two here, 7/5 and 11/10, they would be non-unit fractions. But before you get going on that, could you please do for me the 4 arithmetic starter questions here? And your time-based question today is having a look at this clock. What time will it be in 45 minutes? Have a look at this clock. Tell me, what will the time be if it was 45 minutes later than the time on this clock? So pause me. When you're ready, you can unpause me and I will show you the answers. Okay, I'm going to reveal the answers to this morning's questions in 3, 2, 1. Okay, so which is greater, 7/5 or 11/10? It's 7/5. Can you change 5/8 to 16? It's 10/16. Dividing is 432, and the value of 4 here is 4/10 because it's after our decimal point. Now, if you weren't aware of that one, don't worry at all because our next unit after fractions is decimals, so we'll be having lots of fun there. Now, the time after 45 minutes, well, if I read this clock here, I can see that the hour hand is between the 6 and the 7, and the minute hand is halfway around the clock. It's pointing at 6, so it's 6:30 now. That minute hand is going to go all the way around to here. It's going to move around here. It's going to be 7:15 or 7:15. Okie dokie. Let's get going with multiplying non-unit fractions by a whole number. Okay, here's my little turtle friend. He's seen the question 2/7 or 2/7 times 3, and he has decided that 2 times 3 equals 6 and 7 times 3 equals 21, so the answer is 6/21. 6/21. Do you agree? Can you write down for me, is my turtle friend correct or incorrect, and why you think that? Think back to our multiplying knowledge that we worked on yesterday. Okay, and when you're ready, I will show you whether I agree with him or not and why. Okay, so let me reveal this working out in 3, 2, 1. I do not agree with my turtle friend because when we're doing multiplication, remember that our denominator does not change. It does not get bigger when we times it. So what we're actually doing is we are doing the same as adding 2/7 and 2/7 and 2/7. So if I'm using my single bar model here, I've got it broken up into 7s because that's my whole, and I'm going to add 2, another 2, 4, another 2, 6, and that's going to give me 6/7. So my answer is actually 6/7 because my denominator is not going to change. Okie dokie. Hopefully that's nice and clear for you. Remember, you can always pop along to a daily drop-in session if you want to go over anything again. Okay, here is another example. I've got 2 times 2 11ths. That's my question. I know that that's exactly the same as 2 11ths plus 2 11ths. Okay, I know that I'm going to have a whole of 11, and I'm going to put my 2 11 and then I'm going to add another 2 11ths because I've got to times it by 2. That is going to give me 4 11ths. Okay, I've used my single bar model to help me out here. Okay, what I want you to do is do exactly the same with this question. So 3/10 times 3. Think about what that question actually means. Can you work out what it means when we're adding instead of multiplying? Can you use your single bar method to help you work out that answer? Okay, pause me here and we'll go through that answer together. All right, guys, hopefully you've got an answer in front of you. If you haven't, quick pause me again. I've got 3/10 times 3. That is the equivalent of 3/10 plus 3/10 plus 3/10. Remember, our denominator will not change. So my answer is going to end in tenths. It's going to have a denominator of 10, sorry. So what I'm doing is I'm doing 3 times 3, or 3 plus 3 plus 3, which is 9. So it's going to be 9/10 altogether. And you can see I represented that here in my bar model. I've got 10 parts, because that's my denominator. And I've put in my 3, another 3, and another 3, which gives me 9/10. Hopefully you got that one correct. Okay, here is a word problem for you this morning. A cat eats 2/15 of a bag of biscuits a day. What fraction of the bag does the cat eat in 4 days? So the key information here is a cat eats 2/15, there we go, of a bag of biscuits a day. So every day the cat eats 2/15. What fraction of the bag does the cat eat in 4 days? So what calculation do we need to do here? Well, if we know that every day the cat eats 2/15 of a bag, and we want to know how much of the bag the cat eats over 4 days, we're going to need to times this fraction by 4. Okay, so 2/15 times by 4. You can pause me here if you want to have a go at it yourself, because we have just had a go at the same calculation. What do we need to do here? We need to do the same as this, which is 2/15 plus 2/15 plus 2/15 plus 2/15. Or we can do 2 times 4, which is 8. And is my denominator going to change? It's not. It's going to be 8/15. So over 4 days, the cat eats 8/15 of the bag. Okay, we've got 2/15. Oh, there we go. I've just spoken you all the way through that. I'm not going to repeat myself. So the answer here is 8/15. Okay, here is another method for multiplying fractions. Okay, we can convert the whole number to a fraction over 1. And then we can multiply the numerators by one another and the denominators by one another. So, for example, I've got my 4 here, 3/5 times 4. 4 is exactly the same as 4 over 1. They're identical. They are equivalent. So 4 is equivalent to 4 over 1. That's what it would be like if we were to represent it in a fraction form, because 1 whole is 4 parts. 4 is the 1 part of our group. So I've got myself in a little muddle there. But 4 is the same as 4 over 1, just like 7 would be exactly the same as 7 over 1. They're identical. If you put a whole number and put your over 1 underneath it, that is going to give you the fraction equivalent. So now I can do 3 times 4, which is 12, and 5 times 1, which is 5, and that's going to give me 12/5. Or I can put that back into a mixed number by turning it into 2 and 2/5, because I've got 2 groups of 5 is 10, and I've got 2 left over. Can you try this method for me for 5/6 times 5? So you're going to need to change this into a fraction. What is your denominator going to be? Have a go for me. Pause me here, and when you're ready, I will show you the answer. Okay, let's reveal that answer for you this morning. Okay, it should be 25 over 6, or 4 and 1/6 if you change it to a mixed number. Hopefully you spotted that what you needed to do is put 5 over 1. So 5 times 5 is 25, and 6 times 1 is 6. Alright, let's carry on, guys. Here is your varied fluency this morning. You've got 10 questions for you to have a go at this morning, using the bar model to help you get going. Remember, if you're down here and you want to carry on using the bar method, you can draw out your single bar method to help you out. Have a go. These are on the website, as well as your problem solving and reasoning as well. Remember, if you've got any questions, you want to go through any more examples, or you want to have or you are struggling with one of the challenge sheets today, then come along to a daily drop-in session with me or Mrs. E. Have a lovely Tuesday, guys. Bye-bye.